Hello class 11. In the last video we spoke about pseudo or fictitious forces, and we saw that fictitious forces or pseudo forces comes into play or is real only for an observer in a non-inertial frame of reference, or for that matter in an accelerating frame of reference, whereas in inertial or rather in inertial frames of reference, which are frames of reference which are stationary or moving with a uniform velocity, there is no question whatsoever of something called a pseudo force coming into play. Okay, and by the way, one thing I forgot to tell you about pseudo forces is of course they come into play in non-inertial frame of reference, don't forget. Okay, pseudo forces, I want to talk about its direction. Okay, its direction is always opposite to the direction of acceleration of the body. Okay, opposite to the direction of acceleration of the body. Direction of acceleration of the body. Do not forget this. Okay, acceleration of the body. Like, let's test in case of the examples that I gave in the last video. You are in an accelerating car, and I said, or what we experience in an accelerating car is we get our body, the upper part of our body gets pushed against the backrest of the seat. Alright, now so what is happening? So in this direction is your car moving, and in which direction do we experience that pseudo force? Our body gets pushed against the wall, or rather against the backrest of the seat in this direction. So it is the pseudo force acting in a direction opposite to the direction of motion of the body. Likewise, we discussed about the pendulum moving. Okay, so the car still is moving in that direction, and the pendulum moves in this direction. So to say again, the pendulum is experiencing a pseudo force in a direction opposite to the direction of acceleration of the body. Okay, so an important point, do not forget this. Now today what we are going to talk about is, we are going to talk about another pseudo force which comes into play, of course, in case of uniform circular motion. Not just in case of uniform circular motion, in case of non-uniform circular motion also, of course, this pseudo force that we are going to talk about comes into play, which is called centrifugal force, of course, which is called a centrifugal force. And do not forget, centrifugal force is a pseudo force. Now, since it is a pseudo force, not a real force, therefore get one thing very, very clearly at the very beginning. Centrifugal force is not the reaction to your centripetal force. Okay? Though remember, the magnitude of centrifugal force is also equal to mv squared by r. Alright, mv squared by r was the expression for the centripetal force, if you remember. Okay, now we will see that a centrifugal force also has the same magnitude. Alright, and in case of a body executing circular motion, be it uniform or non-uniform, since the topic that we are dealing with is uniform circular motion, so let us talk about uniform circular motion only. Okay, so if a body is executing circular motion, what happens is the direction of the centrifugal force, so to say, for a person who is in this rotating frame itself. Rotating frame meaning, not rotating frame, a revolving frame. Okay, of course you can also include rotating frames, we'll talk about that. So if a body is moving in this circular path, alright, and we have an observer in that moving body itself. Say for example, you are whirling a stone tied to a thread, okay, and you're whirling the stone, and if say a person is sitting on that stone, on that whirling stone. Now that person is, so to say, in a non-inertial frame of reference. Okay, so for that person, for that observer, so to say, in the non-inertial frame of reference, centrifugal force is true, and of course the direction of the centrifugal force will be radially outward. At any point it will be radially outward. But remember again, centrifugal force is true only for a person, only for an observer who is in this non-inertial frame of reference, rotating or revolving frame of reference. Okay, and the direction of centrifugal force is radially outward. At any point it is radially outward, opposite to the direction of centripetal force, so to say. And I'm also saying the magnitude of centrifugal force will be the same as that of centripetal force. But still, centrifugal force is not a reaction to the centripetal force, mind you. In fact, the word centrifugal itself means center fleeing. Centripetal was, what was that? Centripetal. Yeah, center seeking force. Whereas centrifugal means center fleeing force. Okay? Now, let us try to understand centrifugal force in a better way. Okay, do understand centrifugal is center fleeing, as you can see, directed away from the center at any point, radially outward, and the magnitude is this much. Okay, and of course it is a pseudo force. So let me erase this part. So let us try to understand how centrifugal force is true only for an observer in a non-inertial frame, whereas for an observer who is stationary, so to say in an inertial frame, centrifugal force is not true. Okay, whereas if it was a real force, it should be true for an observer in inertial frame also. It should be true for an observer in a non-inertial frame also. Let me give you the example that you've done in class 10 also, the famous example of a person. See, this is the center, this is a rotating disc. Okay, this is a rotating disc, and we have a person. Let me represent the person by the dot itself. A is the person, O is the center of the rotating disc, and let us consider the disc is not rotating right now. Okay, so A is the observer, so to say. A himself is the observer in the non-inertial frame, and A is holding. Okay, you have a string to which a ball B is tied, okay, and A is holding that string. Now, initially, since the disc is not rotating, what happens is the thread or the string, so to say, is not stretched or tensed. Alright, so the string is loose initially since the disc is not rotating. Alright. And so A is the observer and C is another observer over here in a non-inertial frame of reference. Now, right now, at this instant, A also is in a non-inertial frame of reference simply because the disc is not rotating. Alright, so whatever A is seeing, A is looking at the ball, A is also looking at the string. Whatever A is true for A, so to say, it is the same for C also. Alright, so C will also see and understand, okay, the string is loose right now. Alright, now what happens is the disc starts rotating. Now once the disc starts rotating, what happens is the string gets stretched. Alright, now what will A understand? Now A understands that since the disc itself has started rotating, alright, so A understands there is an, or A will feel, okay, for A there is a centrifugal force that acts on the ball because of which the ball wants to go in the radially outward direction. At this point it wants to go in this direction, of course. So there is a for A, remember. So there is a centrifugal force acting on the ball because of which the ball wants to go away radially outward, because of which of course the string got stretched. And this centrifugal force, center fleeing force, is balanced by the force of tension that is generated in the string. Okay, so this is what is true for A. So for A over here, centrifugal force is true, absolutely true. There is a centrifugal force acting on the ball because of which the string gets stretched, and the string is, so to say, the centrifugal force is now balanced by the tension that is generated on the string. So that is what is true for A. Now what is true for C? Now C also sees the string getting stretched, alright, and C sees that the ball also describes a circular path which is of this size. Alright, so C sees the ball is also describing a nice circular path. Alright, so what is true for C? What is true for C is the ball is executing circular motion, so to say, alright, and C understands in order for this ball B to describe this circular path, there has to be a centripetal force acting, alright, and the centripetal force is given, or the centripetal force comes into play because of the force of tension that is generated in the string. So for C, there is no question whatsoever of a centrifugal force. C only sees centripetal force acting on the ball B, because of which the ball goes on describing the regular circular path. So there is no question whatsoever of the centrifugal force. Now where the thing gets more interesting is when you cut the string. Now when you cut the string, the kind of picture A sees is completely different from what your observer C sees. The picture that these two observers see is completely different simply because actually they are in different reference frames. Okay, one is in an inertial frame and the other is in a non-inertial rotating frame. So therefore what they see, what they observe is completely different. Now let us try to understand what they observe. Let us talk about observer C first. The moment you cut the string, what happens is C simply sees the ball moving in a in a tangential path along this straight line. So if you cut the string over here, what C observes is that the ball moves along the tangent. And that is absolutely true for C. Why? Because so far the string was not cut. The ball was experiencing centripetal force because of the force of tension generated, and because of which the ball was nicely describing the circular path. But once you cut the string, there is no centripetal force acting on the ball B. Okay, because there is no force of tension. So there is no question of centripetal force acting. And from Newton's first law of motion, we know if there is no force acting on a body, if the body is moving, then the body continues to move in a straight line path. Because the body, according to Newton's first law of motion, if no force is acting, has to move with a uniform velocity. It has to execute uniform motion. Uniform motion means same speed along a straight line. So C sees the ball B traveling in this path along the tangential path, that is along the straight line, following or obeying Newton's first law of motion, since there is no force acting. And of course, if C measures the speed with which the ball goes, the speed will be a constant. We are assuming there is no dissipative forces or frictional drag due to the air. Okay, so the ball moves with the same speed, uniform speed in the same direction. So the ball B is executing uniform motion for the observer C. So there is no question whatsoever of centrifugal force for observer C, mind you. But now talking about observer A, what will observer A see? Now when you cut the string, what happens is for A, the ball B is over here when the string is cut at this point. Now when the ball reaches this point, since A himself is rotating, A would have reached over here. So A sees the ball is still straight ahead of him, okay, but has reached a bit of a further distance. Now when the ball reaches over here, A also reaches over here. Now still for A, the ball is right ahead of him, okay, but a bit more farther distance. When A reaches over here, B would have traveled a much more farther distance, much more farther distance, so to say, but still is ahead of him. Okay, so it's like the scenario, if I'm the observer A, that's the ball, so the string is cut, I see the ball over there. Now the ball reaches some distance, A has turned by that very same amount, proportional, okay, or so to say by that same angular displacement. Alright, so it's like this, all the while the ball is right ahead of A. Only thing is, the ball after every instant is going farther and farther away from him, but still right ahead of him, Okay, so what is true therefore for A? What A feels is, A feels or A sees, it's like, the ball goes radially outward for A. It seems to A, since the ball is every time right ahead of him, but only traveling farther distances every time. Okay, so it seems to A as if the ball is going radially outward, which of course for A is possible because of a centrifugal force acting. So remember, centrifugal force is very much true for A. And for A, the ball is going radially outward. Whereas for our observer C over here, there is no centrifugal force acting whatsoever. At any instant, there is no centrifugal force acting whatsoever. And when the string is cut, C is, like I've already mentioned, that the ball goes tangentially away, obeying, of course, Newton's first law of motion. Okay, so for C, when the ball is describing circular path, it is possible because of centripetal force. And when the ball is describing circular path, remember, because of centripetal force, of course, there is no centrifugal force acting, like I've already mentioned, okay, for our observer C. Therefore, centrifugal force cannot be or is not the reaction to centripetal force, remember. So centrifugal force is not a reaction to the centripetal force, centripetal force. Okay, a very important statement, remember.